In this video, we are going to be given equations of circles and we will have to draw them on a grid. We'll also have to decide whether a particular point lies inside the circle, on the circumference, or outside the circle. Let's look at the first question. In question A, we need to draw the circle with equation x squared plus y squared equals 25. Here is the key fact you need to know for this video. The equation of a circle with centre 0, 0 and radius r is x squared plus y squared equals r squared. We'll see why this works shortly, but notice first of all that this equation that we've got in the question is of this form. We've got x squared plus y squared equals something, and what we're saying is that r squared is 25 in this case, and that means r, the radius, is just going to be the square root of 25, which is 5. So what we have here is a circle with centre 0, 0 and radius 5. So it will look like this. Hopefully you can tell by looking at these points where the circle crosses the axes that it does indeed have a radius of 5. Now let's just have a quick look at why this gives us the equation of a circle with centre 0, 0 and radius r. Well, let's consider a general point on the circle. Let's say we're talking about this point here. Now, in general, it's going to have an x coordinate and a y coordinate. Now, we can form a right angle triangle here. This length here is simply x. It is the x coordinate of that point that tells you how far along from the centre you need to go in the x direction. And this length here is simply y. It tells you how far up you need to go in the y direction to get from the x-axis up to the point on the circle. So the length of that side is y. The third side of the triangle is the hypotenuse. It is the longest side. It is the one that is opposite the right angle. Now, this side, this hypotenuse, is actually the radius of the circle. It is the distance from the centre of the circle to the circumference in a straight line. So that there is going to be our radius r. And Pythagoras' theorem tells us that x squared plus y squared must equal r squared, and that's exactly what we have up here. Now, let's have a look at this final part of the question. Decide whether negative 4, 3 lies inside on the circumference or outside of the circle. Well, looking at the graph, we can see for ourselves that negative 4, 3 lies on the circumference. Now, we could actually answer that without using the diagram at all. Remember, the equation of a line or a curve tells us something about the coordinates of every point on that line or curve. So, if a point belongs on the circle, that means its x coordinate squared plus its y coordinate squared must equal 25. And if you substitute the x and y values into here, you will find that negative 4 squared plus 3 squared equals 25. So this point satisfies this equation, which means this point lies on this circle. Here's question B. Pause the video and see if you can have a go at this one for yourself. Here's what you should have found. The equation of a circle with centre 0, 0 and radius r has the form x squared plus y squared equals r squared. Here we've got x squared plus y squared equals 100. That means our r squared is 100. So that means r is just the square root of 100, which is 10. That means we need a circle with centre 0, 0 and radius 10. And that looks like this. Let's move on to this next bit. We need to decide whether negative 4, 3 lies inside on the circumference or outside of the circle. Well, looking at the diagram, we can see that negative 4, 3 lies well inside the circle. So that is our answer. However, just like before, we could work this out without using the diagram at all. Here's how we could show that. Substituting these values into here, we'd have negative 4 squared plus 3 squared. And that works out to be 25, just like we saw on the previous slide. The point is, this is not 100. So we know that the point does not lie on the circle. In fact, this is less than 100. Because our x and y value when substituted in gives us something that is less than r squared, it means we have a point that is inside the circle. Here's the main idea. Suppose we've got a point with coordinates x, y. If you substitute x and y into x squared plus y squared, and you get a total that is less than r squared, that means the point must be inside the circle. If x squared plus y squared equals r squared, then that point is on the circle. If you get x squared plus y squared being more than r squared, so something greater than r squared, then that point xy must be outside the circle. Here's question C. Pause the video and have a go at this one for yourself. Here's what you should have found. X squared plus y squared equals r squared. That's the general equation of a circle. So in this case, x squared plus y squared equals r squared. That means r squared is 1, and that means r is the square root of 1, which is simply 1. That means we want a circle with a radius of 1. That looks like this. Hopefully you can see that the point negative 4, 3 is outside the circle. But again, we could have worked this out without using the diagram. All we need to do is substitute the x and y values into here. And we find that negative 4 squared plus 3 squared is 25. The point is that is greater than 1. So we have a point where the x coordinate squared plus the y coordinate squared is much greater than r squared. So this must lie outside this circle. Here's the final question. Pause the video and have a go at this one for yourself. Here's what you should have got. In this case, we have x squared plus y squared equals r squared. So that means r squared is 50. And that means r is the square root of 50. Now we can simplify this third. This is the square root of 25 times the square root of 2, which gives me 5 root 2. So this is a circle with radius of 5 root 2. Now you can check on a calculator that 5 root 2 is approximately 7.1. So we need a circle with centre 0, 0 and radius 7.1. Before I draw the circle, let's see if we can answer this part just using algebra without any diagram. So, does negative 4, 3 lie inside on the circumference or outside of the circle? Well, let's substitute that into x squared plus y squared. So negative 4 squared plus 3 squared, that's 25. That is less than 50. So what we have here is our x value squared plus our y value squared, and that turns out to be less than r squared. When that's the case, we're dealing with a point that is inside the circle. Just remember this from earlier in the video, we're dealing with this situation here. Our x coordinate squared plus our y coordinate squared is less than r squared. Now the only thing left to do is to draw the circle. and it had a radius of about 7.1, which means it looks like this.